Section 1.6, solving linear inequalities. Our first example, we want to solve an inequality with a variable on one side. So we'll start by adding 8 so we can isolate my x variable. So if I add 8 to both sides of the equation, that tells me that 5x is less than 20. And if I divide both sides of the inequality by 5, that tells me that x is less than 4. If I look at this visually on a number line and represent this on my number line, if I have x is less than 4, I want to make an open circle at 4 and highlight all my values that are less than 4, which would be to the left. This means that if I substitute any value that is less than 4 into the original inequality, I will get a true statement for that inequality. If I substitute 4 or any value higher than 4, that will give me a false statement for that inequality. In example 2, we want to solve an inequality with a variable on both sides. So we'll start by combining our variables here. So we have 2x, we'll subtract 6x, that'll give me negative 4x is less than or equal to, and if I subtract 1 from negative 1, that will give me negative 2. Here I want to divide both sides of the inequality by negative 4. If I'm dividing by a negative, you should remember you need to change the sign of the inequality. So here this will become that x is greater than or equal to 1/2. So because I'm dividing by negative 4, we'll write this in here so we can see it. Negative 4 on both sides. And because I divided by that negative, I change the sign to be greater than or equal to. So here we have that x is greater than or equal to positive 1/2. And if I represent this on a number line, we would have a closed circle and all my values that would be greater than or equal to 1/2 will have shading to the right. Example 3 is solving an AND inequality. So an AND inequality, you can see we have one statement here that negative 2 is less than or equal to 3x minus 8, which is less than or equal to 10. We'll start by adding 8 on the left side here and the right side. This is going to give me 6 is less than or equal to 3x, which is less than or equal to 18. We're going to divide by 3. And that's going to tell me that 2 is less than or equal to x, which is less than or equal to 6. And if we graph this on a number line, we're going to have a closed circle at 2 and a closed circle at 6. And all my solution set will be represented by all the values that are either equal to 2 or greater than 2 or equal to 6 and less than 6. So anything between 2 and 6, including the values 2 and 6, will be a solution of that inequality. In example 4, we're solving an OR compound inequality. So we're going to take each of these inequalities. The first one will subtract 3, and that will give us 2x is less than 2, which means that x is less than 1. And then we'll solve 4x minus 7 is greater than 9. So here we have that 4x is greater than 16, which tells me that x is greater than 4. So looking at this graphically, we'll have an open circle at 1. Everything that's less than 1 will be to the left. An open circle at 4. And everything that's greater than 4 will be to the right.